Alright, so one topic that is covered in TWU's dual credit course that we will not go over here at DHS is systems of equations. However, this is something that you learned both in Algebra 1 and Algebra 2, so I will just go over this with you. So a system of equations is when we have two or more equations and those x and y values are true for both of those equations simultaneously. Now in the past you have learned three methods for solving systems of equations. One is to graph them and then in turn find where they intersect. A second is by the method called substitution. And then a third is a method called linear combination. Now, any of these methods can be used for any system of equations, but we tend to use a particular method depending on how the equations are formatted. So for this one, the y is already by itself, and then I can easily manipulate this equation, can subtract 3x from both sides and get negative 3x plus 10. So when you can get y by itself easily, then graphing is a good way to do it. So if I go to my graphing calculator and I go to y equals and I clear whatever's there and I type in 2x in y1 and then I type in negative 3x plus 10 in y2 and I graph those two lines, and so the blue line, every dot on the blue line is a set of ordered pairs that makes that equation true. Every dot on the red line is a set of ordered pairs that makes that true. This one spot where they intersect is the ordered pair that makes them both true. So I want the intersection. So I can go to second trace, which is calculate, and I can go down to number 5, which is intersect, and I can hit enter. The first curve, the blue one, yes. The next one, the red one, see how your little cursor's on there? Because we only have 2 lines, but if we had more. Do I want to guess? No, I would rather not guess. I hit enter one more time. And there's my point of intersection, 2, 4. And so that is the solution to this system by graphing. All right, this particular system could also be solved nicely by substitution, because I already know that y is equal to 2x. So what I can do is I can take this value for y and I can substitute it where the y is here. So by substitution, I would write 3x plus, and in place of y here, I would substitute this value 2x equals 10. So I would then get 5x is equal to 10, and I would divide by 5 and I would get x is equal to 2. Now once I know that x is equal to 2, I would plug that back in here and I would say y is equal to 2 times 2, so y is equal to 4, and so there is my solution, 2, 4. That's how you do substitution. Substitution is a nice method to use when one of the equations already has a variable by itself. Okay? Alright, in other situations you have equations and neither one of the equations has a variable by itself. So when your equations are formatted this way, then linear combination tends to be the best method to use. So in linear combination, I am trying to get one of my pairs of coefficients to be opposites of each other, so that I can add these two equations together and I would get 0. So I see here that I have a plus 10, and here I have a negative 2, and 2 is a factor of 10. So if I were to take this second equation and I were to multiply everything by negative 5, then I'm going to write my first equation again, just so it's here. And now I'm going to multiply both sides of the equation by -5. So I'll have negative 15x, then a negative times a negative. Oh, so I don't actually want a negative. I want to multiply by positive 5. Let me back up. Positive 5. So that would give me positive 15. 5 times 3 is 15. 5 times negative 2 will give me negative 10y, because I want this to be the opposite. And then 5 times 7 is 35. And then I add my two equations together. So 7x plus 15x is 22x. 10y minus 10y becomes 0. So the key to this method is that these two are going to add up to 0. And then I'm going to have negative 13 and positive 35, which is going to give me 22. And then I'm going to divide both sides by 22, and x is going to be equal to 1. Now, once I have found x, I need to substitute it back into one of the original equations and solve for y. I'm going to pick this second one just because the numbers are smaller. So I'd have 3 times 1 minus 2y equals 7. So I'd have 3 minus 2y equals 7. Subtract 3 from both sides. Negative 2y equals 4. Divide both sides by negative 2. Y equals negative 2. So my solution for this system, let me move that up. My solution for this system is 1, negative 2. X is 1 and y is equal to negative 2.